so I am here. Don't look at the background. I'm going to show you my cute dog. He's just chilling. He always does the videos with me. His name is Jake. Just thought I'd share that today. Okay, so we're doing chapter 6, 6:1 through 6:3. And so let's go ahead and get started with that. Oh, there it is. Okay, so 6:1, definition of percent and converting percents. So we just finished up the chapter with the decimals, and so now we are getting into the percents section, which are a lot of decimals or ratios. So I'm going to go away, there we go, and start writing some stuff out with the definition of percent. So percent, it tells us right there in the name, is per, and then what number do you think of when you think of cent? Think of like a penny, and if there's 100 pennies in a dollar. So this is per 100. That's the definition of percent. So 9%, I'm going to write it in words first, and then we'll actually write it as a fraction. So think of it as 9%, 9 per 100 would be the ratio or fraction. Ratio just means fraction. All right, I know percent has no space in it, but I was being dramatic with that space to remind you that it's per 100. Okay, so now the next one, it says 50 out of 100. This one is not written as a percent. We're going to do that in the problem, but first we're going to write that as our ratio or fraction. So 50 out of 100 would be the unreduced version. So we would reduce that to be 1/2 is the ratio. But I like the 50 over 100 because that's telling us 50 per 100 or 50%. So that's the two answers, the ratio and the percent. And finally, it tells us the most common color, most popular color of car in North America is white, and it tells us that 23 out of 100 are white. Express this as a percent. So we don't need to write it as a fraction first. Didn't say ratio, it just said percent. So it's 23 per, we could just cross off the out of and say per, 23 per 100. That's 23%. And I like to joke around, like that's where the percent sign came from. The 100, it's right there in the percent sign. I don't think that's true, but it's fun to just say. Okay, so let's look at converting percents to fractions. We were just doing that up above the first problem, but now these are a little trickier. Typically the 2-digit percents. So what I'm talking about is like these two, A and B, or down here, C and A. Those problems all have 2-digit percents. Those are typically the easier problems for students to do. The 1-digit or the decimal, those are a little trickier. They aren't, but people just have a little harder time with them. But we're going to do the same thing for all of them. Okay, so first we're going to convert to a fraction. And whenever you convert to a fraction, we want to make sure to reduce that fraction. So we have 67%, 67 per 100. 67, there's net is prime, so that's it. Moving on. 24% is 24 per 100. Now this one we can reduce because 24 is even, so we know 2 goes into both of those. Actually 4, we know 4 goes into 100 because of 4 quarters, so as long as 4 goes into 24, we're golden, and it does. So we have, so we're dividing both of these by 4. That part in red you don't need to write, but just in case you're curious. And we get 6 out of 25. So that is how you write 24% as a fraction. Now, C is a little trickier because it's a decimal per 100. And so it's still the same setup. I'm still going to just write the number, no matter what number I get, over 100 because it was 0.03% or 0.03 of a percent. The extra layer here is we can't have a decimal in a fraction. Just like on part B, we couldn't leave it unreduced. For part C, this is also unreduced, but for a different reason. So what I'm going to do, and we're going to be practicing this moving decimals a lot in this section, I need to move the decimal to the end to make a 3. That's my goal, is I just want that whole number on top. So if I do it on the top, I need to do it on the bottom. Since I moved it 2 places, I need to fill in 2 zeros. I need to move that decimal over 2 places. So that the problem, let me scoot this over a little bit. The answer becomes 3/10,000. You don't need that comma. I'm just putting it there just so it's obvious to you how many zeros I wrote. So 3/10,000 is the answer for C. And 3 does not go into 10,000. All of these numbers on the bottom, the 100, the 10,000, if you had a higher power of 10, they're real easy to check because only 2s and 5s go into them. Now for part B, we had 4, but 4 is just a couple of 2s. So that's why that worked out. So you only need to check the numerator for 2s and 5s just to make it quicker to reduce. Okay, so now we're going to convert to a decimal. And I'm going to write out the first one just like we did on number 4. So it's familiar, but then I'll show you a shortcut. So 33%, we know that is 33/100. That's what it is as a fraction. Now, if I read that fraction, I say 33/100. So I can write that decimal 33/100 with the 0.33. That's 33/100, and that's the answer. Now we don't have to write the decimal, or we do have to write the decimal. We don't have to write the fraction every time. So if you notice the pattern here, what we did was we moved the decimal from the 33, we moved it over 2 spaces to be 0.33. And the reason we did that is because percent 100 has 2 zeros in it. And so the same thing's going to be true for part B. Well, you know what? I'm going to come back to B. I'm going to do C first. So the same thing is true for part C. I'm going to move it 1, 2, and I end up with 16/100 as my answer. For part B, for 2%, sometimes people get confused because they just move it to the front of the 2 and they don't move it enough spaces. So for a problem like that, if you find yourself messing up on the 1-digit numbers or the decimals, just continue to write it over 100, because I can write this as 2/100, 2%. And then as I read that, 2/100 is that second decimal place. So 0.02 is 2/100. The same thing as moving the decimal over 2 places, but many times I see students lose that 0 right there and they write the wrong answer. So if you find yourself writing the wrong answer on the homework, then just do what I did with the fraction. Okay, number 6, we have converting decimals and fractions to percent. So I want to make these into a percent. All of these are different than what we've done so far. So let's look at this. Converting to a percent, I want to write the number I want to write I want to move the decimal, that's what I'm trying to say, the other direction to make it a percent. So I would move it over 1, 2, and I would get 135%. And the reason that works is because 135 over 100 divides out to be 1.35, 1 and 35/100. So we just move the decimal the other direction. The number 1, as a side note, 1 equals 100%. So anything bigger than the number 1, like in part A, is going to be an answer that's bigger than 100%. And anything smaller than the number 1, like every other problem we've done so far, will be a number less than 100%. Okay, moving decimals. I move it 1, 2 places, and I get 3.4%. This was a small number. It was 34 thousandths was the number. So that's going to be a very small percentage. And we see that with the 3.4%. All right, finally on C, we need to find out what that number is as a decimal first. And let me tell you, dividing by 7s by hand is a pain. And it doesn't say what decimal to round to, so we're just going to go maybe to the 10ths place. And so I'm going to divide 15 over 7 in my calculator. And I could tell that it is greater than 100% because 15 sevenths is the same as 2 and 1/7. So this answer is going to be even bigger than 200%. But what I got on my calculator is put a couple of decimals here because we're going to move that decimal and I want my answer to have tenths in it. So let's see, 1, 4, 2, 8, 6. I know it says 5, 7, but I'm just rounding it to 6 right there. Okay, so that's what the answer is, just doing the division. And again, you can do that yourself with the in and out rule. The 15 goes in, the 17 goes out, and you could just do that long division and just keep going for a while until you get a lot of decimal points or numbers after the decimal. But now we can do the problem, which is to move the decimal over 2 places. So we get 214, and I said I wanted to write my answer to the tenths. So 0.2 or 0.3. We look at the 8, and the 8 is telling us to go up. So this will be 0.3. I didn't even think about it when I was writing the directions to say what to round to, so I just kind of made it up on the spot right now. However, you can look at the directions on the problems for that homework assignment, and it'll be clear. So just go ahead and read through that. And if it's not clear and you're getting it wrong because you rounded to the wrong place, just email me and I'll let you know what I can figure out. Okay, we're done with this section. So go ahead and pause the video. And we are back with 6.2% equations, and then also percent increase and decrease. So the percent section is really quick. We just did it in that video really quick. But the rest of this chapter is about word problems involving percent and equations involving percent. So that's what's going to take a little longer. Okay, so looking at this first problem, it says to translate and solve basic percent equations. And so these are all going to have the same keywords in it. They're all going to have is, they're all going to have of, and they're all going to have some sort of what. So this says what number. And so I like to set up all of my percent equations the same way. And here's the outline of that. I say is over of equals P over 100. And anytime, I'll pop in for a minute just to tell you this. Anytime I tell you how to do something, it's more for people that don't already have a way to do it. Because there's another way to do this. And if that's how you like to do it, there's no problems with that. I just like to come up with little, shortcuts or different ways to do things. So that way, if you've tried it before and you can't remember anything else, or you're reading through the book and it's just not making any sense to you, then you have another way to look at it. Okay, so what I mean by this, what number's next to is, what number's next to of, what's the percent? That's what we're trying to figure out for this problem here. And first we're going to translate, and then we'll come back and solve. And so is 60. It says is 60. Of, it says of what number? So I don't know what the of is, but I know that I don't know it, so it's going to get the X. And then finally, 75%. P is what is the percent? So the percent is 75, and then over 100. So I'm basically just saying write the percent as a fraction. You don't even need to reduce it. Just write the percent as a fraction, or P over 100. What we're going to do, the reason I love this, going back to my buddy the butterfly, we are going to cross multiply. So I'm going to write my equation, and it's going to be 60 times 100, which is a 6 with 3 zeros, equals 75 times x. So you multiply across those butterfly wings and we make an equation. It's just like what we did with the greater than less than, where we multiply, and we put the sign in the middle. Only we have to do a little more work, so it didn't really make any sense to write it on top like we used to. So I just wrote it off to the side. And finally, I said I was going to translate first, but look at this. We are doing both at the same time because we're fabulous. Okay, so I'm going to divide by 75 to solve for x. So I take 6,000 and I divide by 75 and I get 80. So the number is 80. You don't need to write units unless it's money or percent. So in part B, I don't need to know the percent, but I do have a money problem, so I will want money in the answer. For part C, it's asking what percent, so I will need the percent sign in my answer. Okay, what is 18% of $23.75? So sometimes it's harder to tell which one goes with which. So the is like, what is the is going with? I don't know, so I'm going to do that one last. But I see the of is right here with the 27.35. I'm just going to make a line so my numbers don't get crossed. Okay, 27.35, that's going to go in the denominator because that's where of goes. I think I just said that backwards a couple times, but just write down the number. I wrote it down correctly, 23.75. Okay, and then I know the percent, so I know P has to be 18. So I have 18 over 100. And it says what? What is my unknown? I don't know what my unknown is. What is it? It's X. That's like a terrible little who's on first pre-algebra edition. Okay, so when you've filled out everything you know and you have a blank spot, that's probably where your X goes. So I'm going to cross multiply again. 100 times X equals 18 times 35. Did I say that number wrong again? Maybe just put me on mute until we're done with this problem because I keep saying that number wrong. Okay, so 18 times that dollar amount. Oops, I had to clear my calculator. I get, typed it in wrong, $427.50. Actually, I'm just going to put 0.5 for right now because I'm not done with the problem. And then finally, divide by 100. 7. And so dividing by 100, you can either do that in your calculator since you already have it, or we move the decimal place over 2 spots because we're dividing by 100. And so I'm going to get 4 point, and I'm going to put 28 because I'm talking about money. So the real answer was 4.275, but since we were talking about money, money is always rounded to the nearest penny. So I rounded, that's how I knew to round my answer, even though it didn't say to round it. We just know that money is rounded. And we have a dollar sign. All right, last one here. What percent of 540 is 189. This one, and we have the of and the is very clearly next to their numbers. And if you were even unsure about the is, you're like, ooh, which way does the is go? Well, the of is over here with the 540. So that had to go that direction. So we have 540 as the denominator, 189 as the numerator because it is over of. If you have a hard time remembering that, just write it down. And you can look at it because, you know, we're not in class. You take your test with notes. So if you have a hard time, write it down. But what I do when I'm trying to remember it off the top of my head is it's in alphabetical order. So is comes first in the alphabet, therefore is goes on top. So is over of percent. I don't know what percent, so I'm going to call it X. You could call it P if you want because it's percent. I don't care. It's an unknown. You can call it whatever you want. And now I get my butterfly wings to cross multiply. So I have, and it doesn't matter what way you write this problem because equal sign. So I've been writing it a certain way every time just because that's how we write out the butterfly wings. But really, if you prefer, you can write 540x on the left and 18,900 on the right because it doesn't matter. The equal sign means we can write it either one on the left and the other one on the right. So I have my number 18,900 and I'm dividing it by 540 and I get, I'll write that out, 540. And I get that X equals 35. Now, double check, it said what percent, so I do need a percent. But the beauty of doing the problem my way, or the way that I'm showing you here, is you don't need to convert your answers. Whatever you get, that's your percent. Whatever you get, that's your dollars. Whatever problem it is, that's all you have to do. And then just put the units. I'm going to make a little line to make it separated. So again, you just put the percent, you put the dollar sign. If you do this a different way, you might have learned it another way and you like that way better, that's fine. If you find yourself repeatedly getting decimal answers for like if you got 0.35 for this answer, then you need to convert it into a percent as your final step. But if you do it the way I'm showing you, you never have to convert it. It will always be in percent. So now we have some word problems. So we're going to do some word problems with percent. And then 5, 6, and 7, these are also word problems, but they're very specific percent increase and percent decrease problems. So the first one, we have shoes on sale. And they're on sale for 20% off. How much will you save by buying them on sale? So we want to know what that discount is. How much are we saving? So what I like to do is just think about this problem and rewrite it in the words we've been talking about. So a pair of shoes is on sale for 20% off. So what I'm asking is, what is 20% of $32? That's a simplified way, that's a question mark. That's a simplified way of writing what the problem is asking for. Because if you go to the store and you want to know how much am I saving, what is that discount? What is 20% of that $32? And once you write it that way, you can see is over of equals P, oh not P, 20 over 100. And I didn't really give myself a ton of room to write with this giant pen. So I'll just kind of go sideways. But we have 100x equals, and then we have 32 times 20. So 640 divide by 100. And so X is going to $6.40. X equals 6.4. So the final answer is $6.40. because it says how much money to save. So we need to know what that dollar value is. And for money, we always write it to the penny. So if there is no number listed in the hundredths place, we just write a 0. Okay, Anne's bill for dinner was $26. The tip is 15% of the total bill. How much should the tip be? So what's the tip? We want to know what, a little thinner there. What is 15% of 26? And this is actually the same setup as before, because we want to know what that tip is, which is the same way you find out what a discount is, which is going to come in handy in the next section. Okay, so we want to know what out of 26 is equal to 15%. Is our what of is our 26. So I have 100x equals, well, 26 times 15 is 390. Divide both sides by 100. We get x equals 3.9. And again, this is a money problem, so I'm going to answer it in money answer. Okay, finally, not a money problem, but it is a word problem that involves percent. It says 1 serving of cereal has 9 grams of fiber, which is 32% of the daily recommended amount. What is the total amount to the nearest tenth? So now instead of giving me the total, like let's go back here. The total pair of shoes was $32. The total bill was $26. And we were adding or subtracting from that to find the sale price or the total bill. Now we know the percent is 9. What's the total? What's the bigger number? So what I'm going to say is 9 is 32%, because we know it says 9 is 32% of what? Of what number? Because that is what we're trying to find, that total number. So 9 of, it's the x, equals 32 over 100. So 900 x equals, no, my x is on the wrong side. 900 equals 32x, because I'm multiplying 9 times 100. I'm multiplying 32 times x. And so finally, I'm going to divide 900 by 32. Oops, wrong color, but that's okay. You get the point. And I get x equals, and my calculator is giving me 28 and 125 thousandths, but the question said to the nearest tenth. So I'm going to cut it off right there, and the answer will be 28.1. And we could just say grams. You don't need to say grams of fiber. We could just say grams. All right, so now we are moving on to percent increase and percent decrease. And so these have a different formula. The whole first 4 problems, including all of these, use this is over of way of writing it out. And now that we are in the percent increase and percent decrease, we are going to have a separate formula, and the same formula will work for each of these. We don't have to have 2 separate formulas. But this is just one of those pages that I mentioned in a previous section. You kind of want to just flag this or highlight it or do something, so when you're flipping through during the test, you're not searching for these formulas. Another option is just to have a separate page in your notebook that only lists the formulas, and just say like 6.2 formulas, 6.1 formulas, whatever formulas you have for this test. Okay, so we want to know how much it went up or down from the original value. So the formula is going to be the new number minus the old number over the old number. So where did it start? Where did it end? And we're going to divide it over the original number. Okay, so it started here. So this is the old number or the original. I usually say original. I don't know why I went old just now, but that's okay. And this is the new number, 90. It started out as 36 and it grew to 90. And so we're going to get an increase. And all that means is we're going to get a positive answer. Plug it in this formula, you'll get a positive answer. So 90 minus 36, because I need to know how much it grew out of the 36 that we started with, because we always put the original or old number on the bottom. So 90 minus 36. What we're saying is this grew 54 inches. What is that compared to the original 36? So finally, 54 out of 36 is 1.5. And since we are talking about percent, we need to write this as a percent. So I'm going to move my decimal 2 places. And this was a 150% increase. You don't need to write increase. It asked you what the increase was. So we knew it was going to be an increase. Also, it gave us a positive answer. Positive answer means increase. So it worked out. Now, I don't really care. Let me come back for a minute. I don't really care if you have the top right. If you did it backwards and you did 36 minus 94, you would have gotten a 54. You just would have gotten a negative sign. So just make sure you keep the answer positive for all of these. Even the decrease, we're going to keep the answer positive. And as soon as you do that, it doesn't really matter what order you write it in. But if you do it with the formula the way I wrote it on the left, you'll always get a positive when the problem says increase, and you'll always get a negative when the problem says decrease. Okay, so during a shirt sale, a shirt was marked down from $70 to $56. So it was on sale. You know, the price went down. It was a decrease. So I expect to see a negative number. When I write my final answer, I just won't include that. So it started off, there's the old price, and there's the new price. So 56 from 70 over 70, because that old or original number is always what goes on the bottom. In problem 5, the smaller number went on the bottom. In problem 6, the bigger number went on the bottom, just because that's the difference between increasing and decreasing. But it's always the original number that goes on the bottom, or the old number. Okay, so we're going to do 56 minus 70. And again, I got a negative, but I'm just going to ignore that because I already knew that it was going down in price because I see that it's on sale. It says the word decrease, so the negative is just reminding us that it went down in price. Okay, divide that by 70, and I get 0.2. I need to move the decimal over 2 places, 1, 2, and I get 20% as my final answer. So basically what I'm saying is the shirt was 20% off. And we can find that just by knowing what the sale price is. We can figure out what the original or what the discount was. Okay, number 7, another sale. The TV's on sale. It was reduced, so we are decreasing it. So if you're feeling a little squeamish right now, you're not really feeling too comfortable with this, pause it right now, do number 7, and then come back and see what the answer I got. And so I'm not going to stop, but if you want to pause, you can always pause at any time. Okay, so it was marked this price, so that's the old price, and then this is the new sales price. So I have $195 minus $225 all over that original television price of $225. And so you notice by doing this subtraction on top, what's happening is we're just trying to figure out how much money it was marked down. It was $225 Now it's $195. So in other words, that's $30. $30 off of the original price. What percent is that? Well, now I'm going to do the 30 divided by 225, and I get a decimal that repeats. So I just usually, for percents, a good rule of thumb is to leave it as tenths. So once I convert it right here, I have a percent that has to the tenths place, 13.3. There's actually more threes after this, so I knew that it stayed a 3. It didn't round up to a 4. And yeah, that's it. So we still have some more with percents, and we're going to do the tax and the discounts more. Tax and tip are very similar, and then the discount in 6.3. That will be our last section, but for now we are going to pause the video and give you a chance to do your 6.2 homework. And we're back. And now you know why I say we're back. Well, I mean, you're here, but look. I told you, it's a terrible time I make every video. So he's just relaxing, so we're back. Okay, let's finish up with this section. Now, this is the title of the section, but as I was going through and doing the homework problems, I decided not to do commission. Yeah, we just have a couple. We just have discount and sales. I know somebody out there, either you or somebody you know, works on commission and you know what I'm talking about. But I figured, you know, commission and sales tax, they're the same formulas math-wise, and every single one of you pay sales tax. And because everyone has at least bought a pack of gum, right? You pay tax on something. And then discount. Lots of people get discounts. I mean, you don't even have to be a couponer or shop the sales to just get a discount because you walk in and something got marked down. So I figured these were the two most applicable applications. And so here we are. So first up, we have sales tax. So Sue bought a new dress for $31. The sales tax was 6.5% of the purchase price. How much was the sales tax? So first, I need to figure out what the tax was. Oh no, that's it. That's what I need to find out. How much was the sales tax? I'll tell you how to find the total, but all we're asking for is the sales tax. So it tells us that the tax was, or that's our verb, was or is, 6.5% of times $31. Now you could do this as an is over of problem, but tax and discount, we're just gonna be multiplying. So we don't have to really worry about setting up that whole equation. Now I did forget to write the percent. That is a big deal because 6.5% is not a 6.5 in this problem. It is going to be a 0.065 because I need to move that decimal over 2 places times 31. Some of you may have a percent button on your calculator. And if you hit that percent button, if you type 6.5% into your calculator, it'll just pop up with that 0.065. So you can try that. You can play with that button. Some people like it and some people it confuses them. So you do what works for you. But I want to take that number and I'm going to multiply it by 31 and I get 2.015 as my calculator answer. So the final answer for the tax is $2.02. I have the dollar sign and I have it round nearest. Now, if I wanted to know the total, you know, everyone's gotten a receipt before. You've seen your subtotal is all the items you bought, and then the total is your items plus the tax. So number 2, we're finding the total. So first we need to find the tax, and then we will add them together to find the total. So the tax is going to be 7% of or times $595. 7% times and then it tells us the purchase price was $595. So as a reminder, don't type in 7. You can type in 7% if your calculator has that button, or you can write it as a decimal by moving that decimal over 2 places like I just did. So 7% times $595 is $41.65. So that's my tax. That's not the answer though, so I don't have a box around it, but that is to the nearest cent, so that's a good place to start. The total cost is $595 plus the tax. So we just take our tax and we add our original price of the camera to it and get $636.65. On the homework and on the quiz, what I see people miss most often is which questions ask for only the tax and which questions ask for the total cost. Because you see they're very similar, but on step 2, I had to do that extra step of adding the camera cost to get the overall total. And so just pay attention to the words in the part with the question mark. It'll tell you if you need just the tax or if you need the whole thing. And here we have the last topic, which is discount applications. And to find the discount, it is exactly the same as finding the tax. And then all we're going to do, since discounts save us money, is we're going to subtract the discount instead of adding like we did for the tax. So this is asking for the overall price, the sales price. And so the discount is going to be, wait, what? I'm thinking way too hard on this problem. It already told us what the discount, I should read it first, shouldn't I? It's $20 off. It's not 20% off. It's $20 off. Why did I even put this problem in here? That's because it just gives us a practice of finding the total sales price. So it already told us the sale. I even wrote it wrong right here. I was just so excited they already gave us the answer right there that I wrote it wrong. Okay, so if I have a tennis racket that's $165 and you're telling me it's $20 off, there's my total. I wonder if I meant to write percent. I probably did. That's probably a typo, but don't worry, we'll get extra practice in number 4 so you get the hang of it. So sales price, you take the original price minus the discount. Here, now we have a percent off. So now we are able to figure out the discount and to actually calculate it. And this problem says just to find the amount of the discount. It doesn't say to find the total sales price. So the discount, we have to work a little harder here. The discount is 25% of or times $36. So when we write that out, we get 0.25 times 36, or if you prefer, 25% in your calculator times, your calculators can do a lot. One of these days I'll make a video on all the stuff your calculators can do, but not right now. Okay, 25% times 36, and we get $9. Oops, dollar sign goes over here. So the discount is $9. You find the discount and you find the tax the same way. You just multiply the percent times the price. The only difference in this section between tax and discount is you add the tax, you subtract the discount. And look at that. I can't remember what time I started this video, but I think it's only been like 45 minutes. Yay, we did the whole section in one video in 45 minutes. Okay, this should be a pretty quick, short section, and then the next module, we are gonna just kind of do this mishmash of different sections from 6 and 5 and 10, I believe, and we will be ready for the test. So we're moving right along. Once we got out of those fractions, it kind of started picking up the pace and moving a little faster. All right, so I will see you in the next video. Bye.